So, welcome back sa another episode of our lecture video series on differential amplifiers. Sir, may napansin ako. Wait lang, sir. Nung nire-recall ko yung experiment number 3 sa LX2 lab, ang natatandaan ko, dalawa yung supplies na ginamit doon eh. Alam ko meron kaming positive VCC and negative VEE na ginamit doon eh. But sa inyo, sir, yung resistor connected agad sa ground. Sa experiment namin, connected yan sa isa pang power supply. Sir, ba't ganon? Okay, so ganito po yan. So yung diniscuss natin before, ang differential amplifier na yon is operating in a single voltage supply. So every time na gumagamit tayo ng single supply voltage, nagkakaroon tayo lagi ng input common mode voltage. Okay? So kapag ang gamit natin is isang power supply lang, tapos ground yung isa, as we can observe over here, required tayo magkaroon ng biasing voltages sa ating input terminal. Pero, is there a way to remove that biasing voltages? Kasi medyo hassle siya, di ba? So, meron pong way. By using dual voltage supply. Or simply, just dual supply. So, sir, paano po yun? Wala na po tayong input common mode voltage. Sino na po magbabias sa ating transistors Q1 and Q2? So, ang mangyayari kapag meron tayong dalawang supply, ganito po ang magiging itsura niyan. So, for VCC, meron tayong positive supply papunta sa ground. And for negative VEE, meron naman tayong negative supply or negative po yung katabi niya, tapos yung positive papunta sa ground. Okay? So, this is VCC and this is VEE. So, ngayon, pwede na natin actually tanggalin yung common mode voltage. So, during quiescent operation, gagawin natin ay iga-ground natin yung ating input terminals. So ngayon kapag grounded yung ating input terminals, ganito po ang magiging itsura niyan. Okay? So ngayon, pinakita ko po yung supply voltage na negative VEE kung saan itong wire na yan connected siya sa negative ng isang power supply. Tapos yung positive ng voltage supply na yan or voltage source is connected to the ground. And we know that for quiescent operation, kapag dual supply voltage, ang ginagawa natin is ginaground natin yung input. So kaya, for DC analysis, diretso yan sa ground. So ngayon, kapag nag-KVL tayo dito, nagkakaroon tayo ng input loop, di ba? So yung base emitter voltage is now provided by the negative supply voltage na VEE. As we can see over here, VEE is actually equal to VBE plus V-tail. Okay? So is there a way to convert a single supply amplifier to a dual supply amplifier? Actually, yes po. Meron po. So, for the sample problem, ang gusto niya is i-convert natin tong dual supply amplifier as a single supply one. So, let's assume that VBE is 0.79. So, let's proceed po. So, ayan, nasa one note na po ulit tayo. So, first, to convert dual supply to a single supply, alamin muna natin kung ano yung supply voltage na VCC. So, sir, paano malaman yung VCC natin ng pang single supply voltage? E di yung gagawin natin, so usually naman si VCC sa si VEE parehas yan, di ba? Laging parehas yan. Yung isa positive 5 with respect to ground, yung isa negative 5 with respect to ground. So kapag drenowing ko yan, ganito po ang itsura niyan, di ba? Ayan. So ngayon, ang gusto natin is tanggalin tong VEE. Pero ayaw natin masyadong maapektuhan yung ating circuit. So ang gagawin natin is ililipat natin yung ground over here. And tatanggalin ko yung ground dito. So ngayon, what will be our new VCC with respect to ground? Kasi as much as possible, ayaw natin baguhin yung ganyang arrangement. Diba? So ngayon, what will be our VCC with respect to ground or this one? So VCC with respect to ground will be equal to 10 volts. Diba? So yun po yung gagamitin nating single supply voltage. VCC is equal to 10 volts. So again, as I have mentioned before, kapag gumamit tayo ng single supply voltage, magkakaroon tayo ng biasing voltage na input common mode voltage. So actually, yun lang naman po yung goal natin to find what is VCC and VICM. So ngayon, what should be the value of VICM? So yung value ni VICM is dependent dun sa tail current natin dito. Okay, so ang goal ko dyan is to convert this dual supply voltage into a single one nang hindi ko binabago yung current. So, ibig sabihin kapag ginawa na natin siyang single supply, magkakaroon tayo dito ng VICM na connected until ground. So what is this voltage VICM ngayon? So we need to compute VICM in such a way that the current dito sa resistor R6 will not change. Okay? So first of all, we need to find the current at R6 or the tail current kapag dual supply voltage. So paano natin malalaman yung tail current sa dual supply voltage? So ang gawin na natin is ibalik natin yung dual supply voltage configuration kanina, which is ganito. Okay, so to find what is the tail current sa ating R6 or this one, kailangan lang natin mag-KVL. So magkakaroon tayo ng input loop dyan, di ba? Kasi this is grounded and this is also grounded. So parang magka-connect lang yan. So similar to this one po. Pero kahit isa na lang i-analyze natin. So ngayon, magkakaroon tayo ng input loop equation over here. Di ba? Makita natin, dadaanan niya is VBE and the voltage VRE. So by doing KVL at that specific loop, ang mangyayaring equation natin will be, so what is VBE? So yung VBE merong binigay doon. Hindi natin pwedeng i-assume na 0.7 yan dahil given sa problem. And ngayon, what is VRE? So actually, VRE is the product of the tail current and the resistor R6. And alam po natin yung value ng R6, which is 1.172 kilo ohms. So makakompute na po natin si ITAIL. ITAIL will be 3.5921 milliamperes po. Okay, so ngayon na-compute na natin yung dual supply tail current. So ang main goal natin dyan is ayaw natin palitan yung tail current kapag kinonvert natin yan sa single supply. So ibig sabihin po, ITAIL dual supply should be equal to the ITAIL single supply. Okay, so let's now draw ang ating circuit kapag it is single supply. Ayan. So ang goal natin yung current dito or yung kuryente dito should be equal dun sa dual supply na current. Okay, so paano natin magagawa yon? So kailangan natin iset si VICM. So we need the value of VICM in such a way na ang ating current dito will be equal dun sa na-compute nating tail current. Okay, so since this is now ground and we have VICM to the ground, kukonect na natin itong dalawang yan. So pwede nyo rin gawin nyo sa kabila, pero since parehas yung VICM na yan, kahit isang side na lang po ang ating i-analyze. So magka-KVL tayo ngayon dito. So ang madadaanan niya is VBE and VRE. Using the input loop equation na, makakompute natin si VICM. Dahil si VBE given po sa problem and si VRE is masasolve natin. VRE is the voltage across this resistor. So ang lumabas po na VRE is 4.21 volts. So meron na tayong VRE. So makakompute na natin yung VICM, which is equal to 0.79 plus 4.21 volts. Ang lalabas ngayon na VICM is 5 volts. So, to conclude, masasabi natin na equal lang pala tong circuit na to na may dual supply dito sa circuit na merong single supply. So ngayon, na-convert na po natin yung dual supply into single supply. So again, to recap lang, para malaman natin yung VCC, pinag-a-add lang po natin to. Okay, yung dalawang 5 volts na yan. And to compute VICM or the biasing voltage, we need to ensure that the tail current in the dual supply one is equal to the tail current in the single supply one. So that's it for this episode. So yun na po ang ating DC analysis for differential amplifier. So I hope natutunan nyo in this episode kung paano mag-convert ng dual supply amplifier to a single supply amplifier. So for the next episode, tayo naman ay mag-AC analysis sa differential amplifier. So I will see you in the next one. Bye!